Okay, guys, this is this next video for Chapter 7. It's going to be 7-3, Logarithms and Logarithmic Functions. This is going to be a fairly short video. We're going to kind of come back to this between 7 and 8, whenever we start graphing more of our functions that we've been talking about throughout the year. But we still need some basics from this lesson before we move on. So, fairly short video tonight. Hopefully it doesn't take. Hopefully I say that and it actually doesn't end up being 20 minutes long. But I'll try to cut through as quick as I can. Basically, what you need to know is the definition of a logarithm, and essentially what it says here is if you look at this blue equation here, that's the graph of an exponential function. Okay, specifically y equals 2x. If you look over here, you have the chart for the table of values to the function y equals 2x. If you would plot those, so -3, would be 1/8, 0 would be 1, 1 would be 2, 2 would be 4, 3 would be 8, so on and so forth. That graph's like that way. Basically, what a logarithm is the inverse of an exponential, which keeps coming up throughout the chapter, is how this logarithm is the inverse of an exponential function. So if you find the inverse of it, you would basically graph it the opposite way. So 1/8 on the x-axis would be at -3 on the y, 1/4 -2, so on, and then 1, 0, 2, 1, 4, 2, 3, 8, 3. It's just the exponentials order pairs flipped. Graphically speaking, like I said, we'll talk about that more later on. Where we're concerned about with today is the algebra to it and how that changes from logarithmic form to exponential form. Because this switch is, number one, the most important thing in this lesson. Number two, it's very important to know how to switch between logarithmic form and exponential form for the next two videos. Because as we go through, we're going to have to switch from logarithmic form to exponential form to solve our equations. So this switch that's right here, this log of base b, that's a base. So log base b of x, that's how you say that. Log base b of x. Down here, if you had look at this one, you say it log base 3 of 27. So back up to this one. So log base b of x equals y, if and only if b to the y power equals x. So if you look down at this example, then you can see, log base 3 of 27 equals y, then 3 to the y power equals 27. I get asked a lot, what is a logarithm? When you take a log with something, what are you finding? Basically what you're doing is you're finding the exponent that you put on the base to give you the log of what you're taking the log of. Okay, so what this equals is going to be an exponent. This is an exponent that you could put on the base of your log to get this result, which once you switch to exponential form hopefully makes sense. What number can you put on the power of, what power can you put on 3 to get 27? And the answer is 3. Okay, 3 times 3 is 9 times 3 is 27. So your log is an exponent. So for now, when we practice these, hopefully that's going to make sense whenever you write the form. Okay, so the question you guys see coming up is going to be to do this one by yourselves. So hopefully you pay attention just a little bit. Basically the way I teach it to do is this. Switch these two and drop log. So the base of your log right here is going to become the base of your exponent. What you equal becomes your exponent, so 2 cubed. And then what you're taking the log of goes to the other side, which is 8. So you can kind of see how you switch 8 and 3, and then you drop your log, and it becomes 2 cubed equals 8. Okay, so for the second one here, once again, 4 to the second equals 16. Switch these two, drop log. Alright, the bottom one there, I'll just go ahead and do this one first. So the same way, even though it's a negative exponent, all the question's asking you to do is just switch the form, not really evaluate or clean up the negative, so you just got to switch the form. So 4 to the -4th equals 1 over 256. So go ahead and figure out what the last one would be. Okay, hopefully you put down 3 to the 6th power equals 729. So it is much more important, to be honest, to know how to do this, how to go from log to exponential. That's the most common. If I had to pick one, that's the one I want you guys to know, going from logarithmic form to exponential form. The bad news for you guys is I don't have to pick one, because you still do have to know how to go the other way. So you're going to have to also know how to go from exponential form to logarithmic form, which is a little harder at first. Once you get used to what you got to do, it's not so bad. So to teach this, basically what I do, I show, first off, I write log, because we're going to logarithmic form, which means log is going to be in our answer, obviously. Next thing I say is, the base that has your exponent attached to it is going to become the base of your log. So you write that as a subscript. I think the lower one's subscript, maybe it's superscript, I don't know. You write it below the log. Now, you also, if you heard me say, your exponent is what your answer becomes. So 3 is going to go to the other side of the equal sign. Hopefully there's enough room there. And then 3,375 goes to the other side. So 3, 3, 7, running out a little room. Give me just a little bit more. There we go, 3375. So once again, get in the habit, kind of practice how you say these. Log with a base 15 of 3,375 equals 3. Okay, so you can put the exponent of 3 onto 15 and would give you 3,375. So a few more examples. So log base 4 of 64 equals 3. And then once again, a little weird. So log base 4 of 2 equals 1/2. Remember, this is your exponent, okay? So you're putting this exponent on this base to get this result. Okay, let's see if you can handle one like that. Go ahead and answer this question here. Alright, so once again, the base on the exponent is going to become the base of your log, so 125. 5 goes to the other side, equals 1/3. Okay, notice how the 5 kind of comes after the base no matter how long the base is. So it's a little bit of funny notation, but you'll get used to it as you work with these more and more. Like I said, it's a pretty short video tonight. We got a couple more here. Basically, the other thing we're going to do is I want you to learn how to evaluate logs. It kind of goes back to the no calculator stuff, mostly because, once again, you kind of have to think about numbers differently in this chapter. So we're going to evaluate log base 16 of 4 without a calculator. Okay. Now, maybe you already know the answer, which is fine. If you don't, here's how you figure it out. First off, you're going to set it equal to a variable, which is y. And the reason why I'm telling you to don't do this with the calculator, I want you to know how to do this switch. Switching from logarithmic form to exponential form, because the next 2 lessons after today, you have to know how to do the switch. You can't just plug it into your calculator, get the answer, be done. You're not going to be able to do that. So practice doing the switch. So you switch it from logarithmic to exponential, so 16 to the y equals 4. And then from there you clean it up just like if it was a question from the lesson prior. So 16 becomes 4 squared, which equals 4 to the first. This is still to the y power. So you get 2y equals 1. So then y equals 1/2. So log base 16 of 4 equals 1/2. Right, if you don't have that down, write it down because I'm going to clear it out real quick. In case you haven't seen it before in your calculator, this log here, right there, if you see the button that lit up, that's your common log. That log is specifically with a base 10. So if you were to do these on your calculator, the only log you could use this button with is when you have a base of 10. To find the rest of them, you hit math. Let me make sure I got this right. I believe it's in here somewhere. This is a live video. I'm not 100% sure. Yeah, there it is, log base. All right, and if you look, it's gonna most of your calculators hopefully by now have these two little boxes with them, and then obviously you're just gonna put in whatever it is. So log base of 16 there, arrow it over to 4, and then hopefully that gives you 0.5, which it will give you the decimal version instead of 1/2. Okay, so if you do need to check yourself, that's how you could do it. With that being said, you have two questions coming up on here. So go ahead and answer numbers 1 and 2. I'm going to pause the video here so you can answer. Okay, so hopefully for number 1 there you got 4 whenever you solved it. Number 2, hopefully you got -8. Remember the fractions from last lesson. To deal with this, I wouldn't move 256 and make it 1 over 256. Definitely move 2 up. Make it 2 to the negative first, which turns into negative y, and then go from there. So 4 and -8 are your two answers. And that's the end of the lesson for this, guys. Like I said, that switching is the most important thing from the lesson. Hopefully that went well. So you have page 472, 13 through 23 odds, and then 25 through 36 all.